Awesome. All right, everybody, I'm going to record this. It's already started. Now let me share my screen. Let's share this one. Okay, so you can see that?
Yep.
Okay, excellent. And now let's kick it into slideshow mode. All right, so I think we are good to go here. Everything looks good there. And I got my notes up here. All right, everybody, we're going to go ahead and get started. My name is Gabriel Cardona, and I am developer evangelist at Ava Labs. And I'm very stoked to be here today. I just want to express gratitude to the Hacker Earth team. Thank you so much for having me. Web3 is an extremely important topic. As we transition from Web 2 to Web 3, it's just a huge paradigm. I was actually in college. I was part of the W3C's HTML5 working group. So the W3C is a World Wide Web consortium that was created by Sir Tim Berners-Lee, the gentleman who created the World Wide Web. And I was very fortunate in college that Google sponsored me to become a member of the HTML5 working group. So if anybody has ever really geeked out on HTML, you may remember around 2009 to 2012, there was kind of a window of time there, but there was a moment in time where it looked like XHTML2 was going to be the chosen winner by the technical plenary committee at the W3C. They had basically envisioned this world where XHTML was the winner. And HTML5 was kind of like a skunkworks project that was spun up by the major browser vendors, Chrome and Safari and Internet Explorer and Firefox and Opera. And it just ended up being the right platform, or it ended up being the right path forward, because it was clear that the web was emerging from a static document, linked scientific documents into an application platform. Can you guys mute your mics out there? Yeah, thank you. I'm getting some feedback on mine. Thank you, I appreciate it. So I just mentioned this briefly to mention that I was kind of there in the transition from Web 1 into Web 2. I think, people kind of traditionally think of Web 2 as AJAX, asynchronous JavaScript and XML. I think of it a bit more like the emergence of the modern web. So CSS, HTML5, modern ECMAScript or JavaScript. So the transition of Web 1, which was sort of like this statically linked documents, into what we have now, which is this very, very vibrant and rich application platform, which is the web, which the web tech has just matured so much in my career. I've been a software engineer for now 10 or 11 years. And actually more than that, I should say, because my son's 13. I started right when he was born. So about 13 years I've been doing this. And what I've seen in the web has just been absolutely insane with regards to the development of the languages and the APIs and the developer tooling and the actual user experience. And so I just mentioned that all to say that we're witnessing something that big as we transition from Web 2 into Web 3. And people often, kind of think like, well, what is Web 3? And Web 3 is really, as I envision it, it's taking everything that sort of Web 2 is and flipping it on its head. So, Web 2 is very sort of top down. It's very mutable. You can just save an HTML document and refresh a page. Web 3 is very immutable. Web 3 really is about empowering people to be in control of their own data and then optionally monetizing their data footprint. And so I think if you're an engineer out there, guaranteed that the web is somewhere in your workflow. It doesn't matter if you're doing IoT, front end, back end, security, DevOps, it doesn't matter. Somewhere in your workflow is the web, I guarantee it. It's one of the reasons, JavaScript is so ubiquitous, despite the fact that it's such an awkward language to work with. Fortunately, we've had all these, amazing developments in tooling like TypeScript and Node.js, et cetera, but the web is somewhere in your workflow. Every single day, the web becomes more and more ubiquitous. And so, Web 3 is a huge paradigm. And so I'm really glad to be here to kind of talk about it. And I'm glad to talk about what's happening at Avalanche, because Avalanche is a really, really important platform. We consider it blockchain 3.0 technology, and we will briefly talk about that here in a moment. So let me go ahead and get my slides going because I've got some notes. So first, I want to just do a brief introduction about who is Ava Labs. So Ava Labs is a world-class team of experts in the fields of computer science, economics, law, and finance. And our offices are located in NYC and Miami, but we have team members based all over the world. I am personally located in the San Francisco Bay Area, which is where I'm coming to you today. We have a handful of people here. Actually, we're talking about opening an office here, but we have people pretty much all over the world. I think we're on every single continent, I think, other than Antarctica. So we're truly worldwide, and we're definitely hiring. And so if anything I talk about today vibes with you, feel free to reach out to me after this, or go to avalabs.org/teams, or avalabs.org/careers, I believe is the correct URL. And you can see we're hiring totally across the board. So the Ava Labs team, as I mentioned, we're passionate individuals with a vision to create a frictionless world by redefining the way that people build and use financial applications. And so the Ava Labs team has collective experience from leading Fortune 500 finance and tech companies to high growth blockchain companies. And so here are some of the companies that my amazing teammates were on prior to joining Ava Labs. Myself, I was at Bitcoin.com, where I was the global director of developer services prior to joining Ava Labs. You can see that on the bottom row at the right. And I have been working in the blockchain space for quite a few years now. And I really genuinely believe that Ava Labs and the Avalanche network are very, very important milestones in the entire blockchain journey. As I mentioned, we think of Avalanche as blockchain 3.0 technology. So it's as big of a paradigm shift in our world as Bitcoin was, and then Ethereum was with smart contracts and tokenomics. Now we have this Avalanche network, which is absolutely amazing, and I can geek out on it for days and days. Briefly, here's our C-level suite. So at the top left, we have our CEO, Amin Sarir, who was a professor at Cornell for over 20 years. And one of his many, many claims to fame is that he was the creator of one of the very first virtual currencies for peer-to-peer systems, which used proof of work. It was called Karma. It was way back in 2003. You can actually go online at the Cornell website and you can find the white paper. So 5 years before Satoshi released Bitcoin, Goon and his team were already solving problems in this space, and he is an absolute block star. I've been following his work for years and years. It was truly an honor when I got a chance to work with him and join Ava Labs, because I'd met him a couple of times at hackathons, and truly one of the most elite thinkers, laser sharp insight and intellect of anybody I've ever worked with. So if you happen to see this, Goon, thank you so much for the opportunity. Below Goon on the bottom left is our president, John Wu. John attended both Harvard and Cornell and was previously the co-founder at Sego and Sherway Capital. On the top right is our COO, Kevin Seknicki. Kevin is a PhD from Cornell, and he was previously at Microsoft and NASA. He's also an absolute block star. Lastly, at the bottom right is our Chief Protocol Officer, Ted Yin. Ted is also a PhD from Cornell and was one of the creators of Hot Stuff, which is the classical consensus protocol behind Facebook's Libra and Diem network. And now he is at Ava Labs working on Avalanche Consensus. So who am I? As I mentioned, my name is Gabriel Cardona. I am developer evangelist at Ava Labs, and I lead our developer relations squad. And so the developer relations squad, it really has three main functions. We maintain Avalanche JS, which is our TypeScript and our JavaScript library. We do partner integrations. So I spend a lot of my time on Slack or Telegram or Discord, helping new teams and new companies understand our technology stack and helping them understand how they can integrate it with their existing technology stack. And then lastly, I go around to conferences and conventions and hackathons, meetups, events like this today, and I give presentations hoping to inspire people to build amazing applications on the Avalanche network. And it is my personal belief that there is no more valuable resource on the planet at this moment in time than a competent, hardworking, and a creative engineer. And the reason I feel that way is because, as I see it, we're at a unique time in the evolution of our species where we really need to solve problems at scale and velocity. We've got a lot that's facing us as a species, and we've really got to come up with solutions to it very quickly and at scale. Fortunately, there have been so many radical breakthroughs in computer science over the last 200 years. So if you go all the way back to Charles Babbage and Ada Lovelace with the difference in the analytical engines, and you come forward to today, over 200 years, there have been so many radical breakthroughs in computer science that we have a toolkit which is unlike any time in human history. So now what we really need is we just need hardworking, competent, and creative people to step forward and build the systems to solve the problems. So there has never been a better time in all of history to have a great idea, find a group of like-minded people, raise capital, change the world, and uplift the human condition. So hopefully I can inspire someone listening to this today to build their game-changing app, and ideally you'll build it on the Avalanche network. And as I mentioned, of course, we are hiring. So if you're in the field of computer science, economics, law, or finance, and anything I talk about vibes with you, check out avalabs.org/careers. We're hiring in biz dev, engineering, marketing, operations, product, probably even more than that. The team is growing despite the current economic downturn in the crypto market. We are still hiring and hiring aggressively. So I know as other crypto companies lay off their people, we're still trying to bring in the very best people, because if you've ever built a product, you know that the hardest problem to solve is getting a great team. You know, the ideas are a dime a dozen. There's an infinite amount of capital out there, especially in the modern world. What's really hard is finding good people. And so we're always on the hunt for good people. So if you feel like you would bring value to the Ava Labs team, please feel free to reach out to me. All right, we got through all of that. Let's get into this. So what is Avalanche? Avalanche is a global financial network for the issuing and trading of all digital goods. And we enable potentially millions of validators to process thousands of transactions per second with near instant finality using a protocol which is completely green and quiescent. And we've paired this high throughput and fast finality protocol with an architecture that can meet the needs of unique financial services and decentralized applications. We accomplish this through this notion of subnets or subnetworks. And subnets allow anyone anywhere to spin up a tailor-made network with custom virtual machines and complex validator rule sets. So the way to envision Avalanche is a network of networks. It is a platform of platforms where we envision thousands and thousands of public and private subnets all emerging into this global marketplace that we call the Internet of Finance. So before we kind of dig into what makes Avalanche special, I want to give a brief history on the evolution of the blockchain revolution. And I suspect that most of the information on the next few slides is not going to be, radical news to many of the people watching this, either today or in the future. But I've always found that to really appreciate where you're going, it helps if you understand from where you're coming. So very briefly, let's cover the evolution of the blockchain revolution. So blockchain 1.0, let me move this. I don't know what you guys can see, but I see a Zoom element on the screen. I'm going to swap it over here. So blockchain 1.0 was Bitcoin. And so in the beginning was Bitcoin, and Bitcoin was good. And Bitcoin proved to the world there was this need for a robust and a decentralized payment network. And it started its life out as peer-to-peer electronic cash. For better or worse, that's not ultimately what it grew into. It's now much more akin to digital gold. And I'll admit I'm a big blocker. I was pretty salty about that for a long time, but I've matured a lot over the last decade, and my viewpoint has definitely matured and changed as well. Now I realize that Bitcoin has really grown into a hedge against inflation for the mom and pop investor. And so really briefly, what exactly is inflation? Because it's certainly in the news a lot right now. In economics, inflation is a general increase in the price of goods and services in an economy. So what are the long-term impacts and effects of inflation? When the general price level rises, each unit of currency buys fewer goods and services. Consequently, inflation corresponds to a reduction in the purchasing power of money. So as I personally see it, inflation is really like a silent form of theft. And you'll often hear people say that taxation is theft, but at least with taxation, you can point to some things that are common utilities and infrastructure that we all depend on, so you can point to the roads, or you can point to the police, or you can point to the military, and you can say, well, that's what our taxes are used for. But with inflation, your purchasing power is simply going down continuously with nothing that you can point to in return. And 1 out of 5 US dollars that have ever been printed in the entire history of the United States were printed in 2020. So let me repeat that. 1 out of every $5 ever, 20% of all the US currency that's ever been printed, 1 out of 5 were printed in the year 2020.
Wait, I have a question.
Yeah, what's up? Yo. Okay.
We can add the questions if you want to message in the chat, and we can get back to them after. Let's ask the questions in the chat channel, and we can get to those at the end of the Q&A.
I'm very sorry.
It's all good.
So I wanted to say something about Bitcoin. So I know it's been dropping a lot because COVID and gas prices and Joe Biden.
Let's just wait till the end.
Yeah, let's let's take the questions at the end. Thank you, I appreciate it.
Coin.
So like I mentioned, 1 out of every $5 that have ever been printed were printed in the year 2020. So consequently, the purchasing power of every single person listening to this today, their US dollar has decreased. Perhaps not 20% just yet, but it's definitely decreased a lot in the last couple of
I
years.
fucked in the pussy.
Hey, can you mute your mic, homie? Thank you. And so that trend is going to accelerate. And I most certainly feel it living in the San Francisco Bay Area, where every single thing I pay for, so my rent, my bills, my groceries, my gas, my utilities, everything have increased in price or they've decreased in quantity. And so this is potentially what the beginning of hyperinflation looks like. And if you don't think that hyperinflation can happen in the US, well, I would say check out Zimbabwe or Greece or Venezuela or Argentina, etc. So Bitcoin and other cryptocurrencies such as Avax, they allow you to opt out of inflation. And so I really do encourage you to do that. Trust me, your kids and their kids will thank you for that. And so as big of a leap forward as Bitcoin was, it still has its downsides. So here they are. Namely, Bitcoin is very slow. It only does a handful of transactions per second. It does not have fast finality. It takes about an hour before you can be confident that your transaction won't be reorged out from under you. It's not lightweight and green. So perhaps you've heard there's a meme that goes around that Bitcoin burns more energy every day than some nation states. I actually don't think that's as big of a long-term problem as some people make it out to be, because I'm a big believer in renewable energy. So every single hour, enough energy falls on the planet in the form of sunlight to meet over 100% of our energy needs, including fossil fuels, renewables, and nuclear. Every single hour, enough energy falls on the planet in the form of sunlight to meet 100% of our energy needs. So really the problem is about harvesting this energy, storing it and transporting it, which are all problems that are being solved right now within our lifetime. So again, I don't think in the long term, Bitcoin burning so much energy is a huge problem, but it's certainly a short-term problem. Namely, it's really bad optics. So you often see headlines that say like crypto is even worse for the environment than you thought. And they're almost certainly referring to what I'm talking about here. And that's that Bitcoin's proof of work burns more energy than some nation states. Bitcoin has a scripting language. It's creatively named Script, but it's incredibly archaic and cumbersome to use. It's stack-based and it doesn't feel modern. So if you've sort of come of age in the modern era of Golang and TypeScript and Python, etc. And lastly, it doesn't have tokenomics. We're really native tokens. Technically, there is an opcode in the script language, which it's called opreturn, and it enables you to write 80 bytes of arbitrary data to the blockchain. And you can actually encode asset creation and minting and transferring and burning commands. And then you can write wallets which can tease out those 80 bytes and decode them. And so you can have, sort of crude tokens on Bitcoin, but it's really a technical hack, and the tokens aren't native to the Bitcoin virtual machine. So in summary, Bitcoin was a huge leap forward, and it kicked off a financial revolution, but it left a few things to be desired, and it inspired engineers to try and do better. And so I want to sort of close my thoughts on Bitcoin by saying, Bitcoin had a really, really radical impact on the lives of many people, myself certainly included. I got my first Bitcoin in 2011 from Gavin Andreessen's faucet. So Gavin Andreessen was the guy who took over the keys of the kingdom when Satoshi stepped away, and he created the very first faucet. So if you're familiar with crypto, you've probably been to a faucet at some point and put in an address and got a little drip of crypto to help you on-ramp you into the ecosystem. This was the very first faucet ever, and I got my Bitcoin from that faucet, and I fell down the Bitcoin rabbit hole in 2011. And it really changed my life. And I suspect I'll never emerge from that rabbit hole. It's taught me so much about technology. It's taught me about money. It's taught me about social dynamics and so much more. It's given me a career. It's really helped define the last chapter of my life. And so I have extreme gratitude for Satoshi. And my wish is that he or she or they or it, whatever Satoshi is out there living their best life. I hope that Satoshi is happy and healthy and working on the next generation of amazing technology. All right, so blockchain 2.0 is Ethereum. And Ethereum is a decentralized app which enables developers to launch their own dApps on top of it in the form of a smart contract. And prior to Ethereum, if you wanted to launch your own dApp, then you had to roll your own network. And this led to a very bespoke environment where few projects were able to reach the network effects required to tip and go mainstream. So by enabling devs to launch their own dApps on Ethereum, it enabled a huge network effect. And this led to a wave of innovation around tokenomics and initial coin offerings, non-fungible tokens or NFTs, decentralized finance, DeFi, yield farming, prediction markets, distributed autonomous organizations or DAOs, so much more. And I just remain a huge fan of Vitalik and his entire team because, of course, I know he didn't do this by himself. It takes a team to really do something amazing. I hold Vitalik in especially high regards. I think he's one of the great thinkers of our age. And in my eyes, he's still a young man. I don't know how old he is, but I suspect he's probably in his 30s, maybe. I don't think he's 40 yet. So in my eyes, that's young because I'm a big believer in life extension. And certainly within our lifetimes, we're witnessing life extension. And that's a trend which is going to also accelerate. And so I imagine that I view Vitalik as still as a young man, and I suspect his best days are still ahead of him. And so the analogy I often think about is that if you know Linus Torvalds created Linux, and that was his chapter 1, but then he came back with chapter 2 and created Git. And so, if you work in modern software, you're probably using both Linux and Git in your software flow. And I'm very interested to see what Vitalik ultimately does for his chapter 2. And so now we get to blockchain 3.0. And at Ava Labs, we view Avalanche as blockchain 3.0 technology. And similar to Bitcoin and Ethereum, we are introducing a handful of new paradigms, which we're going to go over today. We're going to discuss how Avalanche Consensus is the third major paradigm over 40 years in the field of consensus. We'll discuss how Avalanche is unlike most other existing blockchains in that it is a network of networks instead of a single virtual machine and a set of validators. And we'll also dig into virtual machines, what they are, how they fit into the Avalanche network. And then lastly, we'll discuss how Avalanche enables developers to spin up their own tailor-made networks with custom virtual machines and complex validator rule sets. Okay, so first off, Avalanche Consensus. What is consensus? If you work in the blockchain space, or if you're, if you're interested in the blockchain space, you probably hear the word consensus a dozen times each day, but what is it exactly? Quite simply, consensus is the process by which a group of individual validators come into agreement on a decision. So that's really, it's that simple. How do you get a bunch of people or machines to agree on a decision? And it is a very rich field of computer science, and it goes back at least 40 years. So as I mentioned, Avalanche Consensus is the third major paradigm. Again, I'm not sure, do you see this zoom element on the screen or no?
Nope, it's not visible.
Okay, awesome. So as I mentioned, Avalanche Consensus is the third major paradigm in the field of consensus. The first was called classical consensus, and it goes back to the 70s and 80s. And classical consensus has low latency and very, very high throughput. It's lightweight and it's green, but it's not very scalable nor robust, and it performs poorly in adversarial conditions. In 2008, 2009, when Satoshi Nakamoto released Bitcoin, the world was introduced to the second major paradigm in the field of consensus, what ultimately became known as Nakamoto Consensus. And Nakamoto Consensus is very scalable and robust and decentralized, but it doesn't have low latency. As I mentioned, it takes around an hour for you to be sure your transaction is sufficiently settled so you won't experience a reorg. It doesn't have high throughput. So as I mentioned, Bitcoin only does a handful of transactions per second. Of course, I am aware of second layer solutions such as the Lightning Network and et cetera. I'm referring to the layer 1 Bitcoin protocol and network with regards to this particular slide. And Bitcoin or Nakamoto Consensus is not lightweight or green. As I mentioned, Bitcoin burns more energy each day than some nation states. And lastly, Nakamoto Consensus performs okay in adversarial conditions up to the famous 51% attack. In 2018, a pseudonymous group going by the name Team Rocket released a white paper on the Interplanetary File System, the IPFS, describing the third major paradigm shift in the field of consensus. So this new breakthrough was known as Avalanche Consensus. And Avalanche Consensus is really the perfect storm of features from classical and Nakamoto Consensus. It's very scalable, robust, and decentralized. There are currently around 1,500 full block and vertex producing validators on the Avalanche network. The protocol theoretically enables millions of validators, so it's very, very decentralized. Avalanche Consensus has low latency with sub-second immutable and irreversible finality. There is no notion of a reorg attack on Avalanche. So within literally the blink of a human eye, your transaction has completely settled for all time. Avalanche has high throughput with 4,500 transactions per second, and it's very lightweight and green. You can run it on a PC, you can run it on a MacBook, You can run it on a VPS, drop it on the cloud, and in the future, you'll be able to run it on Internet of Things devices. And Avalanche Consensus is parameterizable, so it performs very well in adversarial conditions. So I have this demo. We'll see if it works. Sometimes it doesn't, sometimes it does. Okay, it's going to work. Sweet. So technically speaking, Avalanche is a metastable consensus protocol inspired by epidemic protocols and gossip networks. And the process used to determine whether a transaction is preferred or not is referred to as repeated random subsampling. And here we have a really great demo created by our Chief Protocol Officer, Ted Yin. As I mentioned, Ted was one of the creators of Hot Stuff, which is the classical consensus protocol behind Facebook's Libra or DM network. And he's now at Ava Labs working on Avalanche Consensus. So in this demo, the squares represent different nodes, and the color of the squares, the color of each square represents its current proposal. So in this, is this transaction blue or is this transaction orange? And briefly, it's worth noting that Avalanche Consensus can handle non-binary decisions. So for example, you can give it 5 options instead of 2, and it will still reach immutable and irreversible consensus. But for the sake of this demo, and in most transaction-related decisions, we're going to go with a binary decision, which is blue or orange. The darkness of the color is the node's conviction in that proposal. So it really, really believes that it's blue, or it really, really believes that it's orange. And when I click play here, each node will begin repeatedly and randomly sampling its peers and changing its own color and its own conviction based on their responses. And all nodes will collapse to the same color in the end. And so you can see it only takes a couple rounds of sampling and the entire set will avalanche into consensus. I want to play that one more time because I think it's really pretty sweet. So again, you can see that it only takes a couple rounds of sampling and the entire set will tip and then avalanche into consensus. And so hopefully that gives you a little bit of an intuition around how Avalanche Consensus works. It's actually, it's surprisingly, it's unintuitively simple how it works. So that's why I think this demo does a great job of giving you an intuition on that. Let's see if I get to the next slide. All right, network of networks. So that's Avalanche Consensus, which is the third major paradigm in the third major paradigm shift in the field of consensus. Excuse me. So now let's discuss how Avalanche is a network of networks. As I mentioned, Avalanche is different than traditional crypto networks like Bitcoin and Ethereum that have one virtual machine and one set of miners or validators. Avalanche is actually a network of networks with compound network effects. So, sorry, my notes. So we have this really great slide. This is from CryptoSec on Twitter. You can see at the bottom right, the @CryptoSec. Go check him or her out. I don't actually know their gender, but thank you so much if you see this CryptoSec. Absolute block star, incredible depth of knowledge on blockchain technology, not just Avalanche. So go check out this person on Twitter. Go check out their Medium post. Very, very insightful and deep thinker. But I absolutely love this visualization. So I took it from one of his or her Medium posts, and I've been using it in my presentations for the last few months. So here you can see that the gray oval in the center represents the Avalanche network. Within the network are many different subnetworks or subnets, which are represented by the different little circles. And in each of those subnets are green squares, which represent the different virtual machines that are running on those subnets. And a virtual machine is a blockchain. So the line between the subnets show that you can actually move assets between the different subnets. And at the top, you can see Ethereum and Bitcoin and Cosmos. And then there's lines representing the ability to bridge assets from those other networks into the Avalanche network. And currently, bridge.avox.network supports bridging assets from Ethereum into Avalanche. And recently we announced that Bitcoin is live on bridge.avox.network. So since we went live, it's been less than a year. I believe it's probably been 9 or 10 months since the original Ethereum Avalanche bridge went live. We have seen over 300,000 transactions with over 50 billion US dollars in assets move back and forth between the Ethereum and the Avalanche network. And as I mentioned just last week, maybe 2 weeks ago, we announced there's Bitcoin support. So we now have a new, what we're calling a Web3 operating system called Core, and it has this bridging functionality built into it. So if you want to bridge actual BTC Bitcoin from the Bitcoin network into the Avalanche network so that you can take advantage of all this different DeFi and yield farming and staking and all of this stuff. You can do that now, and you can do it through the core wallet or operating system. So go check that out as well. And so, as I mentioned, there's already been $50 billion in assets which have moved back and forth between Ethereum and Avalanche. And now that we've added Bitcoin, we suspect that number is going to go much, much higher. And I often say that Avalanche's subnet architecture is really primed for compound network effects. So what do I mean by that? So most everybody has heard of a network effect, which is technically, it's known as Metcalfe's law. And so Metcalfe's law says that a network's value is proportional to the square of the number of nodes in the network. So for example, if a network has 10 nodes, its inherent value is 100, right? 10 by 10. So in other words, a product or service gains additional value as more and more people use it. And a great example of a network effect is the telephone network. So if only one person has a telephone, it's not very useful. For every additional person who plugs into the telephone network, then the entire network grows in value for every other user. But I think perhaps the canonical example of a network effect, of course, is money. If only one person accepts a currency, then it's not very useful at all. But for each additional person that accepts the currency, then it becomes more valuable for every other user who can then use their currency for goods and services. And we witnessed this, for example, when Bitcoin bootstrapped as a network. In the beginning, you could just run your computer and mine 50 Bitcoin every 10 minutes. And many, many people did that, but there wasn't much use in it. No, you can really do anything with it. And then famously, the dude bought the pizza for like 10,000 Bitcoin, which ended up being, worth a crazy amount of money today. And so some people dog that guy. But if you roll back to the time when he bought bought one or two pizzas for 10,000 Bitcoin, that was one of the very first transactions that ever happened. And so we kind of witnessed more and more people accept Bitcoin for goods and services, and that actually helped grow the value of the network. And so now cryptocurrency is accepted all over the world for many, many different goods and services. And that's a great example of a network effect, a network becoming more valuable for every user as more and more users opt into the network. So that's network effects, but what are compound network effects? Compound network effects are technically known as Reed's law. And Reed's law states that the utility of large networks, particularly social networks, can scale exponentially with the size of the network as the number of possible subgroups grows much more rapidly than either the number of participants or the number of possible pair connections. So even if the utility of groups available to be joined is very small on a per group basis, eventually the network effect of potential group membership can dominate the overall economics of the system. And Avalanche's subnets are absolutely designed and primed for compound network effects. Next, we have virtual machines. So a virtual machine defines the application level logic of a blockchain. And in technical terms, it specifies the blockchain state, a state transition function, transactions, and then an API through which users can interact with your blockchain. And every blockchain in the Avalanche network is an instance of a virtual machine. The way I envision this, and I think it's a good sort of paradigm, how you can think about this, is it's very akin to a class in object-oriented programming. So a class is like a description of an object. It's a template from which you can instantiate as many different objects as you wish. And each of these objects, though they are derived from a common template, they're all unique and logically separate entities with their own state. So similar to a class, a virtual machine is a blueprint or a template from which you can instantiate as many different instances of a blockchain as you wish. And each of these blockchains, though they are derived from this common template, they're all unique and they're logically separate entities with their own state. So as a developer, when you write a virtual machine, you don't need to concern yourself with lower level logic like networking or consensus or the structure of your blockchain. Avalanche does this behind the scenes so that you can focus on the things that you want to build. You can focus on your special sauce. So why would you want to use virtual machines? So as I mentioned in the beginning, at first, blockchain networks only had one virtual machine with a predefined static set of functionality. And this rigid monolithic design limited what blockchain-based applications you could run on such networks. So people who wanted custom decentralized applications really had to create their own entirely new blockchain network from scratch. And obviously this requires a great deal of time and effort. It offers limited security. And generally, it just resulted in a very bespoke and fragile environment where not many blockchains were able to get off the ground and achieve the network effects required to tip and then go mainstream. As I mentioned before, Ethereum made a huge step towards solving this problem with smart contracts. So the developers didn't need to worry about networking and consensus, but instead just creating their own decentralized applications. But it's still kind of hard. The Ethereum virtual machine has low performance, and it imposes restrictions on smart contract developers. For example, Solidity and the other few languages like Viper and whatever else is available for writing Ethereum smart contracts, they're just unfamiliar to most developers and most programmers. They're not very expressive, and they don't really fit into the rest of your development workflow. Avalanche virtual machines make it easy to define a blockchain-based decentralized application. So rather than new limited languages such as Solidity, developers can write virtual machines in Golang, and using a gRPC API, you can actually write your virtual machine in a language other than Golang, as long as your virtual machine implements a certain interface. And most languages out there have a gRPC library. So we envision a future where there's going to be virtual machines written in all of the modern languages. So that should excite you. If you're a developer and you're used to working with Rust and you want to create a WASM VM, or you use C# or C++ or something really obscure like Julia or whatever your language is that you really, really love. If there's a great modern gRPC library and you can implement this interface, then you can actually write your virtual machine in that language. And this is enabled by the RPC chain VM. So this is a special virtual machine that uses Go plugin and wraps another virtual machine implementation. So the C chain, for example, which is an instance of the Ethereum virtual machine, runs this way. So RPC chain VM has two important parts. There's a server and a client. The server runs in its own process and allows the underlying virtual machine methods to be called via gRPC. And then the client runs as part of Avalanche Go and makes gRPC calls to the corresponding server in order to update or query the state of the blockchain. And then we also have subnets. So lastly, as I mentioned, a subnet is or subnetwork is a dynamic set of validators working together to achieve consensus on the state of a set of blockchains. So each blockchain is validated by exactly one subnet, and a subnet can validate many blockchains, and a node can be a member of many different subnets. So to visualize this, it's a very heterogeneous or rich and diverse. Picture this. A VM is the application level logic of your blockchain. It's the template, and it can be instantiated into many different blockchains, some of which are public and some of which are private. A blockchain is an instance of a virtual machine. Each blockchain is validated by exactly one subnet. A subnet can be on a spectrum of public or private and can validate many different blockchains, including many instances of the same virtual machine. So you can launch a virtual machine multiple times within a subnet. And a node can be a member of many different subnets, validating many blockchains, including many instances of the same virtual machine, some public and some private. So Avalanche is very, very heterogeneous. It's very rich and diverse in character. And subnets manage their own membership and can require that their constituent validators have certain properties, and that can be very useful. So why is that very useful? So for example, regulatory compliance. So Avalanche's subnet architecture makes regulatory compliance manageable, and regulatory compliance is a huge part of the blockchain story, which has yet to be told. But as a blockchain, I believe that the blockchain has potential to be as transformative as the web, and potentially even greater so. That's why I dedicate so much of my time to this. The web has absolutely changed my life in a huge way, and I believe that the blockchain has the potential to be as transformative as the web. We're witnessing the emergence of Web3, like I was saying earlier. It's just as big of a deal as when we went from a static web into the HTML5 world, if not even bigger, because this is about empowering people. This is about taking the web and actually empowering, as I mentioned before, all of the different things that you think about with Web 2, sort of turning them on their head with Web 3. And so regulatory compliance is going to be a part of the story as the blockchain goes worldwide, and each of the different legal jurisdictions tries to wrap their minds around it. And so a subnet, I should say, can require certain validators meet certain sets of requirements. So for example, you could say all of the validators in my subnet must be located in a certain legal jurisdiction, or all of the validators in my subnet have to meet a certain KYC AML requirements, or all of the validators in my subnet have to hold certain licenses in this particular country, for example. There's also support for private blockchains. So you can create a subnet where only predefined validators can join and create a private subnet where the contents of the blockchains are only visible to those validators. This is ideal for organizations interested in keeping their information private. There's also separation of concerns. So in a rich and heterogeneous network of blockchains, some validators will not want to validate certain blockchains because they simply have no interest in those blockchains. That's totally legit. So the subnet model allows validators to only concern themselves with blockchains that they care about, and this reduces the burden on validators. And then there's also application-specific requirements. So different blockchain-based applications may require validators to have certain properties. Suppose there's an application that requires large amounts of RAM or large amounts of CPU power. A subnet could require that validators meet certain hardware requirements so that the application doesn't suffer from low performance due to slow validators. So subnets are incredibly powerful and dynamic. And so as an example, we have the primary subnet, which is what launched when we went live with our mainnet in August of 2020. So we call it the primary subnet, and it has 3 chains on it. It has the X chain, the P chain, and the C chain. And we'll quickly look at those here. So this is a data visualization of the primary subnet, or the default network, which, as I mentioned, has been live since August of 2020. There's 3 chains on it. In the middle, we have the X chain. As I mentioned, a blockchain is an instance of a virtual machine. So the X chain, which has got the X because it's for exchanging assets, it's an instance of the Avalanche virtual machine. And it is what's known as a DAG, a directed acyclic graph. So it has partial ordering, and it's really great for, it has super high throughput, and it's parallelizable and prunable. It's great for commutative transfers and simple asset transfers, simple tokens. You can create assets there. We call them Avalanche native tokens. AVAX was actually issued there. So AVAX is a fixed cap asset. There will only ever be 720 million AVAX. They were created on the X chain. The X chain has what's known as UTXO. So if you ever worked with Bitcoin, you know it has unspent transaction outputs, which is quite different from Ethereum, which just has accounts. So there's kind of these 2 different models. The X chain, or the Avalanche virtual machine, is a DAG. It's a directed acyclic graph. It has partial ordering, and it uses UTXOs. And then on the left, we have the P chain. So this is the platform chain. This is kind of like our administration chain. It is a linear blockchain. So it has total ordering, but it also uses UTXO. And you can do things like add validators, you can add delegators, you can launch subnets, you can add blockchains to the subnets, you can instantiate virtual machines as blockchains, you can add subnet validators, etc. on our P chain. And then on the right, you can see we have the C chain. So this is an instance of the Ethereum virtual machine. This also is a linear blockchain, so it has total ordering. It's great for smart contracts. This uses the account-based model. So in the middle, you have a DAG, which uses UTXO. On the left, you have a linear blockchain, which uses UTXO. And on the right, you have a linear blockchain, which uses accounts. So it's, again, very, very rich and heterogeneous. This is just an example of what you can do with virtual machine. And there's so much more you can do. We have several custom virtual machines, which we've written internally at Ava Labs to sort of show the expressiveness of the Avalanche API. But on the right, we have the C chain, which is an instance of the Ethereum virtual machine. It has 100% backwards compatibility with existing Ethereum developer tooling. So if you use MetaMask or Remix or any of those tools, Hardhat, Truffle, any of that stuff, all you have to do is add the Avalanche C chain as a new network ID, and you can just deploy your compiled smart contracts directly to our network with very, very minor integration. It's one of the reasons our C chain blew up. We basically took Nakamoto consensus and removed it and replaced it with Snowman consensus. So Snowman consensus is like a sister protocol to Avalanche consensus. Avalanche consensus is for directed acyclic graphs. Snowman consensus is for linear blockchains. So basically there's kind of a restriction that says there can only be a one child, one parent relationship, but it's basically Avalanche consensus for linear chains. It's called Snowman consensus. And so, as I mentioned, the C chain does everything that Ethereum or any other Ethereum virtual machine does. So Binance or any of the instances of the EVM out there. So of course you have smart contracts and NFTs and DeFi and all of the stuff that I mentioned earlier. And in the middle, you can see a little red line going between the 3 different circles. And that signifies that you can actually swap assets back and forth between these 3 virtual machines on the primary subnet. So you, for example, you can create an Avalanche native token on the X chain. You can swap it over the C chain. You can wrap it in what's called ARC20. an ARC20 interface, and then it's an ERC20 interface basically, and you can use it in DeFi, for example. And so you can actually swap assets back and forth between the X chain and the P chain and the C chains built in native to the protocol. And this is incredibly powerful when I was talking about compound network effects. And you can actually do this between subnets as well. So whenever you fire up a subnet, there's already several that are live on Avalanche today. You can use bridges to move the assets back and forth between the subnets. In the future, we will have native to the protocol cross subnet asset transfers, similar to what we have here for virtual machines. And that's what enables this compound network effect. So you can imagine today you spin up a subnet, you launch your own instance of the EVM on it. You're the only dApp running on there. So we envision this world of application-specific blockchains. It's how we plan to scale horizontally and how we sort of get around the blockchain trilemma. We imagine that every single blockchain will just launch as its own, or every single app, every single dApp will just launch as its own blockchain. So you won't even have to share your subnet with any other dApps, and you get all of that throughput and finality and all of the validator resources just on your blockchain. You can spin up as many subnets as you want. So launch a new subnet for every single blockchain or virtual machine. And so, as I mentioned, if you launch your own subnet today and launch your own instance of the EVM, you automatically have access to the billions of dollars in TVL on our primary subnet, all of, tens of thousands or hundreds of thousands of users, whatever. You can immediately just bridge those assets and users over to your subnet in your virtual machine. And you can create an asset on the primary subnet, and you can use that asset as the gas or fee asset on your subnet, so you don't have to use AVAX. You can create your own asset, and you can change the tokenomics of, we burn AVAX in our world, but you don't have to burn it. You could give it to the validators. Again, it's very, very rich, and you can do whatever you want. So that's kind of the primary subnet. So again, so in summary, Avalanche is a global financial network for the issuing and trading of all digital goods. And we enable potentially millions of validators to process thousands of transactions per second with near instant finality using a protocol which is completely green and quiescent. And we have paired this high throughput and fast finality protocol with an architecture that can meet the needs of unique financial services and decentralized applications. We accomplish this through subnets. So subnets allow anyone anywhere to spin up a tailor-made network with custom virtual machines and complex validator rule sets. Avalanche is a network of networks. It is a platform of platforms, and we envision thousands and thousands of public and private subnets to all emerge into this global marketplace that we are calling the Internet of Finance. So thank you so much. I want to thank the Hacker Earth team again for having me. It's very honored. I want to, obviously, I always express gratitude to the Ava Labs team. It's truly an honor and a pleasure to work with all the amazing people on that team. I really do feel like the work we're doing is going to resonate for generations. The analogy I use is the guys and gals who created the DARPANET in the late 60s or the TCP/IP stack in the early 70s. Their work is arguably having a greater impact today than it ever has 50 years later, because the web becomes more and more ubiquitous with each passing day. And that's what I imagine our work is going to do. I don't think it'll take 50 years for our work to have the kind of impact that it's going to have, because the pace of change is rapidly accelerating within our lifetime. Within the next 10 years, we'll experience more technological innovation than we did in the previous 100 years. And so again, I don't suspect it'll take 50 years for our work to have impact, but I do believe that our work will be having an impact in 50 years. So to all the people in the future who are watching this, what's up? Hope you guys are living your best life in the future. And so, as I mentioned, my name is Gabriel Cardona. I'm developer evangelist at Ava Labs. You can find me at CG Cardona, both on Twitter and Telegram. Feel free to reach out to me. And thank you so much. Hope everybody's having a great one. All right.
That was awesome, Gabriel. Appreciate it, man. I know that there were definitely a couple questions that went into the message channel. Again, if you can also, to the participants, thank you all for joining. If you could direct a lot of these messages maybe to the Discord, or Gabriel's been kind enough to give out his contact information for Twitter and Telegram. But if there are any, quick questions that you want to ask right now, got about 6 minutes left, so I can open it up.
I see one here that says, we are trying to raise seed funding, but bear market is a big barrier. Is there any way we can launch our own subnet and later bring our own validator nodes? We can lock our tokens in escrow. So yeah, of course, you can launch your own subnet, and we recommend having a minimum of 5 validators. But you could just spin up 5 of your own nodes. in theory, you could launch it with one. You could launch a subnet with one, validator, but it's kind of like it's not that decentralized in that case. But yes, you can obviously add as many validators as you want in the future. Whenever you create a subnet, you create what are called threshold control signatures. So for example, you say, here's an array of 3 addresses and the threshold is 2. So in the future, 2 out of these 3 addresses need to sign a threshold control signature for me to be able to add or remove validators, or for me to be able to instantiate virtual machines and basically make any changes to this virtual machine. So yeah, you can launch your own subnet today. You can add validators in the future. Sort of the primary barrier to entry is that you have to also validate our primary subnet. And today it takes 2,000 AVAX to become a validator. That's a relative high barrier to entry, even with the price of crypto having gone so low in the past couple months. It's on our roadmap for sure for that value to go down. That's just sort of a number that's been in place since we went live with the network in August 2020, but for sure you will not need to stake 2,000 AVAX in the future. We imagine in a world where there's millions of validators on IoT devices and phones and everything all around the world. So yes, you can launch a validator, or you can launch a subnet today and bring on validators in the future. We have a lot of great tooling. There's a subnet EVM, there's a subnet CLI, we have Avalanche CLI, so you can even do all of this stuff in a development environment and get used to our workflow. And then when you're finally ready to push to the mainnet, you can do that. Can you DM me your email? You reach out to me on Twitter or Telegram, and I can shoot you my email. Says, can I talk about some business use cases for subnets? So yeah, the big one that we see is, like I mentioned, application-specific blockchains. So a great example is there was a dApp on Avalanche that launched in Lisbon, or at least the team decided to launch on Avalanche back in September or October of last year when we had a big Avalanche house in Lisbon. I was there, and Cardona and DeFi Kingdom both were doing it. I think at one point Cardona was a third or so of the traffic that was happening on our C chain. There's a great chart. I saw it just this morning. I wish I could show it to you, but I didn't get a screenshot of it. But it showed the different number of transactions and the gas that was being burned on our C chain. And when they launched on their own subnet, the C chain, the amount of gas being used just totally dropped and almost flatlined because so much of that traffic was happening from this one specific blockchain. So really, the business use case of a subnet is an application-specific blockchain, and that could be anything. But if you have a DEX, if you have a dApp, if you have a GameFi, if you have any of this stuff, the value of having it on your own subnet is that you won't have to compete with other apps on a subnet for performance or gas. So you're always going to get the lowest amount of gas burned and the basically the most inexpensive transactions. Good stuff as usual. Thank you. I appreciate it. Good stuff as usual. Is it possible to create a custom blockchain and use current validators without the need to give the subnet ID to who needs to validate the blockchain? So let me think about this again. Is it possible to create a custom blockchain and use current validators without the need to give the subnet ID to who needs to validate the blockchain? No, because, well, I'm not sure, it's phrased a little weird, but as the validator owner, you obviously know the subnet ID. And whenever you add a subnet validator to your subnet, you have to pass in the subnet ID. So in that particular case, it's kind of public because the subnet ID is what we use to do. We have like a faucet where you can add your subnet to our faucet, or we have Snow Trace, which is like an explorer. And so in that particular case, the subnet ID is public. And then the last one is, I would chase you via Telegram or email. Awesome. It says, can you test all your dApps with Avalanche CLI? Can you test all your dApps with Avalanche CLI? Yes, you can. You can test your dApps with Avalanche CLI, and you can do, we have we extended the EVM and have this thing called stateful precompiles. So you can actually do more with Solidity and the EVM and Avalanche than you can in Ethereum. And we have this thing called stateful precompiles. So you can imagine if there's something that's awkward or cumbersome to implement in Solidity, like a cryptographic function or something like that, you can actually implement it in Golang, and then you can do a stateful precompile, and it basically creates a smart contract address that you can then use in your Solidity code. And when the Solidity code calls that smart contract, the call will pass right through to the Avalanche Go stateful precompile. So that's pretty rad. Okay, I think I got through all the questions. Thank you so much, everybody. Again, CG Cardona on Telegram or Twitter, hit me up.
Awesome. Thanks, Gabriel. Really appreciate it. That was absolutely amazing. We'll make sure to get this posted back into the Discord shortly after it is downloaded. But again, thank you, everyone. And Gabriel, that was phenomenal. So thank you so much, man.
Thanks, you guys.
I will see everyone in the next workshop. Have a great rest of the week and enjoy the long weekend if you're in the States.
Cheers.